When we talk about relationships, relationships can be shown in relationship in a table, relating x and y in a table, relating x and y on the graph. It can also show up as a relationship of x and y in an equation as well. So the last way that relationships can be shown is going to be in words. And all four of those things can be related to each other. There is a relationship in words can be expressed as a relationship in an equation, an ordered pair in a table, or on a graph. So here it says, write the relation for the following problem. A bus travels 30 kilometers an hour away from the school, and it starts 5 kilometers from the school, and it's traveling away. What are the two quantities being related? Well, the two quantities being related are the time in hours and is being related to distance from home. And this represents our x and y. Now, it is useful to recognize that 30 kilometers an hour is a rate that often will be the slope in the problem. We have a starting point of 5 kilometers. That often ends up being our y-intercept. Okay, so when we talk about the two quantities, one is a dependent variable and the other is independent. So in this case, the distance is dependent on the time we're traveling. So the distance from home is our dependent variable. Distance depends on time. I'm going to draw this table out. It's always good to put in the starting point in my table. That happens to be my y-intercept. Okay, that often is the y-intercept. And then we're going to use the ratio of change, or the rate, to get other numbers in this table. So after 1 hour, they've traveled 30 more kilometers, so they're now going to be 35 kilometers from home. After 3 hours, they've traveled 30 kilometers an hour, so that's 90 kilometers, plus the initial 5 kilometers is 95 kilometers now. And I'm just going to put in 1 more hour here. At 4 hours, they've traveled now 125 kilometers away from home. So I can then show this on my graph. Okay, on my graph, I'm going to just say that's going to be 1, 2, 3, 4. There's my 4 hours. And the distance scale, since we're talking about less than 200, I'm going to go up by maybe, let's see here. Let's say that's going to be 50, 100, 150, like that. So at 0 hours, I'm at 5 kilometers, right about there. 1 hour, I'm going to be 35, so maybe somewhere around here. At 3 hours, we're at 95, so I'm just down there. And 4 hours, I'm at 125 kilometers. And again, we could have chosen any points, because any points would give us the same line. And that's what I'm looking for. I'm looking for this line. And this line represents the relationship between time and distance for this particular problem. So I have my relationship in words. I have my relationship as a table, as a graph. And I can also come up with an equation for this if I know the ratio of change in a starting point. I can put it into the equation y equals mx plus b. So I'm just going to write that here. This is what I want. That represents the ratio of change. This here represents the ratio of change. Just change that to red here. And this represents the y-intercept, okay, where it starts. So there's where it starts. So I need to show the ratio of change. I'm going to do it arbitrarily between any 2 points. Between those 2 points is going to be the ratio of change, which shows up in my table. So it's going to be plus 60 for every 2 hours. The ratio of change is 60 kilometers over 2 hours. As a unit rate, that works out to be 30 kilometers per hour. And notice that that was the rate in the problem. So the starting point we've established as at 0 hours, it's 5 kilometers. So we have the 2 parts that we need to write the equation for this relationship. So the equation for this relationship is going to be that distance is equal to 30 kilometers an hour times the number of hours plus the starting position, which is 5 kilometers. So there is my y equals mx plus b equation.